Let's take a look at this problem. We got 4x to the third, e to the 4x plus 2 minus y squared equals e to the xy. And it says find dy dx implicitly. So I want to find our derivative. We'll take the derivative of everything where it's sitting. So we'll take the derivative of 4x to the third e to the 4x plus 2, then plus the derivative with respect to x of negative y squared equals the derivative with respect to x of e to the xy power. Okay, well, this first one here, this is the product rule. So this will be p and this will be q. I need p prime and q prime. P prime, the derivative of 4x to the third is 12x squared. And q prime, the derivative of e to the 4x plus 2 is e to the 4x plus 2 times the derivative of 4x plus 2. Chain rule applied to the quotient, or chain rule applied to exponential function. Okay, derivative of 4x plus 2 is 4, so we've got 4e to the 4x plus 2. So this first one is p prime q plus p q prime. P prime we said was 12x squared times q, which is e to the 4x plus 2, plus p, which is 4x to the third, times q prime, which is 4e to the 4x plus 2. Okay, let me double check all that. P prime 12x squared times q plus p, which is 4x to the third, times q prime, which is that. Okay. The derivative of negative y squared is negative 2y, but since we're taking derivative with respect to x and it's really a y, we have to put on a y prime. The derivative of e to the xy is e to the xy times the derivative with respect to x of e xy. That's the chain rule applied to exponential functions. Derivative of e to the xy is e to the xy times the derivative of the exponent. Okay, so that gives us 12x squared e to the 4x plus 2 plus 4 times 4 is 16 x to the third e to the 4x plus 2 minus 2y y prime equals. Now here, the derivative of xy. Well, this is a product rule. This is p and this is q, so we'll need p prime and q prime. P prime, the derivative of x is 1. For q prime, the derivative of y is 1, but then we have to add on a y prime. Again, anytime you're taking derivative with respect to x and it's a y, you have to throw in your y prime, which is the same as dy dx. So our formula is p prime q plus p q prime. So for this side, we got e to the xy times p prime, which is 1, times q, which is y, plus p, which is x, times q prime, which is y prime. Let me double check that. Okay, y, and then that times that. Okay. So I'm going to have 12x squared e to the 4x plus 2 plus 16x to the third e to the 4x plus 2 minus 2y y prime equals, and I'll multiply this through because I don't want any parentheses. E to the xy times y gives us y e to the xy. E to the xy times x y prime gives us x y prime e to the xy. Okay, now we want to get everything with y prime on one side, everything else on the other side, and it doesn't matter which side you take things to. Probably easiest for me to take negative 2y y prime to the right side and this y e to the xy to the left side. So I'm going to have 12x squared e to the 4x plus 2 plus 16x to the third e to the 4x plus 2 the y e to the xy becomes a negative y e to the xy equals x y prime e to the xy. And when I take the negative 2y, y prime to the right side becomes a positive 2y, y prime. Okay, so I'm going to have 12x squared e to the 4x plus 2 plus 16x to the third e to the 4x plus 2 minus y e to the xy. And I want to factor out a y prime over here. And that leaves us x e to the xy plus 2y. Now we're trying to get y prime by itself, so we're going to divide both sides by what's behind our y prime. So I got 12x squared e to the 4x plus 2 plus 16x to the third e to the 4x plus 2 minus y e to the xy all over x e to the xy plus 2y. And same thing on this side. So divide both sides by the same thing. So x e to the xy plus 2y. Now over on the right side here, that's going to cancel with that. And so we got y prime is equal to 12x squared e to the 4x plus 2 plus 16x to the third e to the 4x plus 2 minus y e to the xy all over x e to the xy plus 2y. And that's our answer. Now I could get rid of one of these e to the powers, but I can't get rid of both of them. So I might as well just leave the answer in that form.